Okay, just picking up on my last video, I was in the process of substituting 1 in for x. So this would be my top equation. I'll put in 1. If I get 1, I'll have 3a plus 4. In the middle equation, when I pick up with 1, which would be my left point where it starts, I plug 1 in here, I'll get 2a plus b plus 1. And then my right side, let me change colors so that way I don't mix the two up. My middle right end point will end at 2, it says. If I plug 2 in here, 2 squared is 4, 4 times 2 is 8, so 8a plus 2b plus 1. And then my bottom equation starts at 2, and 2 cubed is 8, 8 times 2 is 16, so I have 16b minus 2a plus 3. So I'm going to set my equation up with my blue ones by setting my y values equal to one another. So this is 3a plus 4 equals 2a plus b plus 1. I'm going to get all my a's and b's on one side. So this will be negative a plus b equals 3. This one is finished. Let's get the two red ones set equal, because the y values need to be the same. This is 16b minus 2a plus 3. So I'm going to move all my numbers over here. This will be negative 2. This will be negative 10a and 14b. Alright. So I'm going to do linear combinations. I'm going to divide these all by 2. So it's going to give me negative 1 equals negative 5a plus 7b. And I'm going to multiply this one by negative 5. And I'm going to cancel out this a. So negative 5 times 3 is negative 15. This will become positive 5a. And then this will be negative 5b. Okay. Now we can actually do this vertically. So that would be 2b equals. These cancel out. And that would be negative 16. So it looks like b is going to be negative 8. So let's plug negative 8 into one of my equations, either one here, I'll probably plug it in that one. So I have 3 equals negative a minus 8. So I'm going to add a over, I'm going to subtract 3, and I get negative 11. So a is negative 11, b is negative 8. Alright, moving down to the next guy, which would be number 27. Okay, it's asking us, is it continuous at positive 1? So all we have to do here is do our limit as x approaches 1 from the left. Okay, so if I put in something like, sorry, I need 9s here, from 0.999. This will be 2 times 0.999 minus 1. I just have to see if this is going to be undefined. So this is basically going to be 3, 2 minus 1, which will be 3 over 1. So this is going to about 3. How about the limit from the right side? So this would be the left side. This would be the right side. So now we're looking at 1.001. This will be 2, 1.001 minus 1. So this is a little more than 3, a little more than 2. So I know the limit's going to exist. So therefore, okay, if I do direct substitution with just 1, right? This would be 3 times 1. This is for f of x. And that would be 2 times 1 minus 1, so 3 again. Okay, so is the function continuous? Yes, the function is continuous at 1. Now, yes, it is not continuous at 1/2, but at 1 it is continuous because it has a left limit, it has a right limit, and therefore the limit exists, so it has to be continuous at 1 to have a limit. So your proof is in the actual showing of the work of the limit. Right? In the last problem of your review, I'll should say last two, determine vertical asymptotes. This is just what you left off with. So the top would be x plus 3, x minus 3. The bottom would be x minus 3, x minus 3. So as you can see, one of your x values where it's undefined will cancel out. So we're undefined at x equals 3. Yes, this one was removable, but we still have one left. So this is non-removable. Therefore, we have a vertical asymptote at x equals 3. Okay, 29. GCF out of the top leaves you with x squared plus 3x plus 2, which then would be factored to be x plus 2 times x plus 1. On bottom, these are conjugates, so that's plus 2x minus 2. The x plus 2's cancel out. So yes, we're undefined at x equals -2 and +2. However, this one's removable. This is your non-removable one. So we will have a vertical asymptote at x equals +2. The one at -2 is canceled out. So there's your review sheet. Hit me up with questions via email. See me in class, do what you need to do, but good luck on your test, guys. We'll see you soon.